Okay, greetings again, everyone. This is part two. We're here in the midterm exam. We're getting now into chapter three on foundation systems, the part that covers chapter three, and we're on question 31. So, which best describes a concrete slab on grade foundation? So we're starting with foundation systems. We're looking at those types. On 3.4, we have types of foundation systems, and those are outlined. You might want to read through these and see which one best describes what that slab on grade condition is. Concrete slab on grade is right down there. When is support for excavation required? So we can kind of go into this section, which is underpinning. And underpinning refers to the process of rebuilding or strengthening the foundation of existing buildings or extending it when new excavation is deeper than the other. That's some of that underpinning. Excavation support system. This is when it's sufficiently, excavation can be bent, terraced, sloped at an angle less than the angle of repose. So we're talking about angle of repose, or we're talking about some sort of other kind of system. So you'll want to, when is it required, is only when a slurry wall is required or when the sides of a deep excavation exceed the angle of repose of the soil. So it's a slurry wall is just a type of support system. This best describes when that support is required, when the angle of repose, when the size of a deep excavation exceed the angle of repose of the soil. The angle of repose is that when you just dig a hole in the soil, creates that kind of angular inward sort of thing that happens when soil settles on itself. So that's 32. 33, what is the most common form of spread footing? So here we have shallow footings. Here we have spread footings. The most common forms of spread footings are strip footings and isolated footings. So we can look over here and see that that's probably both. What forces must a foundation system transfer? So this is an important one to look at when we look at forces on a foundation system. So if we look down here, foundation walls, foundation system must transfer the lateral loads of the superstructure to the ground. The horizontal component of these lateral loads is transferred to a combination of soil friction at the bottom. So we can look at what that's about. We also know that it does need to gravity load from the superstructure. So we're looking at both of those things. Make sure you kind of read through that carefully so you understand that question. Question 35. What is the purpose of a control joint in a concrete slab? So the control joint, we can get to that. Where's our control joint? Sorry, bouncing through here. We're going to bounce through a couple of these systems because they're a little less relevant to us. And we get to here, 3.1, control joints. Control joints create lines of weakness so that the cracking that may result from tensile stresses occurs along predetermined lines. So look at that and make sure you understand the difference between an isolation joint, a construction joint, and a control joint. So that's a little bit of a tricky question. A thickened edge slab is ideal when, so here's that thickened edge slab, in warm or temperate climates when little or no ground frost occurs. There it is right there. Embedment lengths of pole foundations vary according to, so this is when we look at pole foundations. We don't do a lot of these, but when they do happen, we need to understand what varies their circumstance. So we can start to read through this and you can start to see where you might get to that right here. Down here, we sort of have some of those design conditions and what that answer might be. What best describes cased piles? So understanding the difference between piles. There are cased and uncased piles. These are different types that we can deal with when we're talking about doing deeper foundations. So when you get to 3.25, that's the pile foundations. Here are these different types. Here are the cast in place cased, uncased, pedestal, micro piles, all those things that happen there. And you can kind of try to make sure you read through that to understand which of these best describes a cased pile. What's the characteristic of a masonry bearing wall system? So now we might be getting into walls and I'm at the end of that chapter, excuse me. We're getting into wall systems, chapter 5, and where we're getting to walls and floors and roofs, which was that third reading. In masonry, so here we have wall systems. Here is a masonry bearing wall. There are some of those factors. There are some of those factors. You can see if that what aligns and what is a true characteristic. What is the minimum cover for steel reinforcement within a concrete column? This is just a good rule of thumb to just know. So you can look at that and you can see right there is that minimum cover, 1.5 inches. Usually in concrete speak, we'll sometimes say 2 inches, just because we know that the diameter of the bar it can sometimes be 1/2 inch, and sometimes it's confusing to people when we say clear, if that's clear to the middle of the bar or clear isn't clear. But 1.5 inches is the minimum clear. That we mean is to the edge of the reinforcing bar. Minimum clearance for reinforcing within a poured concrete footing when cast against and permanently exposed to the earth. What is the minimum clearance for reinforcing within a poured concrete footing? So here's a poured concrete footing. Here's the minimum cover when concrete is cast against and permanently exposed to the earth. Should be 3 inches. Got it? Got it. There it is. So again, all these questions are in order of the reading. If you are finding yourself flipping back and forth in the readings, then you know you might be a little bit off in terms of where to find these answers. So just make sure you're kind of going through in sequence. Which of the following would be a treatment to concrete after it sets? So if we look at here's some concrete surfacing. Treatment after the concrete sets. Down there, a bush hammered or ribbed surface bush hammered. So look at what those are and find out which one's right. In masonry walls, what is the wythe? So we talked about this word. Wythe is an interesting word that it's really worth knowing. We're going to get to, there we go, masonry walls. And so here we can start to talk about the wythe of that wall. And you can read in here and start to understand what that means, and you can understand what best describes that. It should be the minimal nominal thickness. It should be that last answer there. The answers in your quiz will likely shuffle. This is a preset to the exam, so if you're following along with this exactly and trying to take the exam with this video, you're going to have some trouble. So just make sure that you take the time to be thoughtful about how you take this exam. What is the minimum nominal width of a non-reinforced masonry bearing wall? So now we get into some of these tables that we have. So here's an unreinforced masonry wall, non-reinforced masonry bearing wall. And here we have some information about how about what those widths need to be when they're non-reinforced. So you can start to look at those minimum wall thicknesses right there. In a masonry wall, what is the typical spacing between vertical joints from center to center? So vertical joints are these little guys right here, these vertical joints. And what is the typical spacing? It should be 16 inches. So that's something we should always know, is it's 8 by 16 is that vertical masonry unit. Which best describes a concave masonry joint? So if we get into the masonry joints coming up here, zipping through some of this stuff, zipping through these wall sections. Here we go. Mortar joints. There's a concave, V, weathered, struck, flush, a raked joint. Concave is right there. It's a tool joint that compressed and shaped with any tool other than a trowel. There you go. 47. What best describes a running bond? This is another one that we should all just sort of know. This is a part of, should start to become part of our vocabulary. The typical layup of brick is or concrete block is called a running bond, where the joints are centered on the solid unit below, and that runs that way all the way up. The most common. Which best describes a random ashlar stone masonry? So we get into stone masonry, we're kind of zipping through this glass block, we don't really care. Here's some of that types of coursing. We're looking at random ashlar. So there's random ashlar, stones in discontinuous courses. There it is. In structural steel framing, the webs of columns are oriented parallel to the long axis of the structural frame. So we're looking now getting the steel framing. The webs of columns. So we're looking at column spacing. Orient the webs of columns parallel to the short axis. Here it says parallel to the long axis. So that's obviously got to be false. That's just a matter of the strength of a steel H or I beam or W beam, depending on which supplier or which person you're talking to. Steel can lose strength rapidly in fire. We should all know that that's true. That is very, very true, and that's what that fire resistance is about. And estimate how much floor area can a W14 by 14 column support. So we have some help here. Oh, I'm getting ahead of myself. Sorry. See, I'm bouncing back and forth. Here it is, estimated guideline for steel columns. So a W14 by 14 support 12,000 square feet. Here we go. Which of the following factors when considering the selection of exterior wall finishes? So we get into exterior wall finishes. So we're looking at light gauge steel frame, there's some balloon framing, platform framing, wood framing, sheathing, wood columns. So, obviously we missed it, right? So, we may want to just keep looking into here and seeing what are those factors when we look at exterior finish materials. And the answer on this one should be all of the above. So just make sure you read through these carefully. Platform framing is a light wood framing having studs only 1 story high. So let's look at, there's balloon framing, there's platform framing, only 1 story high, true. What is the maximum unsupported height of a 2x4 wall at 16 inches on center? Right down here in this little table, that'll tell you that. Sole plate is a nailer for ceiling finish. Look over here in this little section, you can see a sole plate. That is not a nailer for ceiling finish. It's very much the opposite of that. That's going to be false. In wood stud framing, 2 2x10s carrying only roof loads can span how long for a window or door opening? So if we want to look through here, we can see if we can find a chart. Here we go, are your headers, 2 2x10s, roof only, 8 to 10 feet. There we go. These are rules of thumb. These need to be engineered, but these are good rules of thumb. Post and beam framing may qualify as heavy timber framing. So let's see what that says. Wood post and beam may qualify as heavy timber construction. So that's true. What is the minimum recommended slope of a flat roof? So we still call certain roofs flat roofs, right? But every roof has a slope. So the minimum slope of a roof that we call a flat roof is about 1/4 inch per foot. On reinforced concrete roof slabs, the wear course is below the roofing membrane. This is an important thing to really understand the difference between these built-up roof systems. And here you can see the wear course is above, always above, so that should be false. What best describes a Pratt truss? So let's see if we can get the truss types. Here we go. So a Pratt truss is right here. Here's a Belgian, Warren, raised chord, flat truss, all these different truss types. And you can read through this to determine what the best answer is. Open web steel joist systems are similar in layout and construction to steel joist systems. So let's see if we can figure out that. So open web are similar in layout, so that's true. In rafter framing, the ridge is, so if we go to rafter framing, here's the ridge, structural horizontal member supporting the upper ends of the rafters. So roof the horizontal line, the intersection. So it might be that we want to look at the rafter differently. That's the ridge beam. We're looking at the ridge itself. Ridge, horizontal line. There we go. There it is. There's our answer.